Good morning, dear students. In this small video, we can understand how to solve the solid shaft, hollow shaft comparison problem. Observe this fourth question in exercise. Two shafts of the same material and of same lengths are subjected to same torque if the first shaft is of a solid circular cross section and the second shaft is of hollow circular section whose internal diameter is 0.7 times outside diameter and the maximum shear stress developed in the shafts or it is same. Compare the weights of the shafts. This is the question. This is the answer. We will solve this problem very easily. So these are the two shafts. Case 1, it is solid shaft having length L, diameter D1, and it is subjected to torque T. Due to this torque, the maximum shear stress is at outer layer of the shaft, that is T, tau maximum. And this is the hollow shaft. It is subjected to same torque and it is developing same maximum shear stress. The dimension is same as initial shaft, that is L, and diameter, outer diameter is D2, shaft 2 is D2, and it is internal diameter, it is a internal hollow, it is a hole, so it is small d. So now it is given as d is equivalent to 0.7 times d2. The ratios between d1, d small d and capital D as given, that is d2 is d1 is equivalent to 0.7 times d2. Now we can I have solved this problem already, so for saving of time I am showing how to solve it, that's all. So this is the initial torque, is the first shaft torque, that is the relation between torque and shear stress. So it is having diameter d1, that is pi d1 power of 3 divided by 16 into tau is the one of the torsion equation. Here we are getting the maximum shear stress, that is tau. So it is tau maximum, it is also tau, but same maximum is tau. And for this shaft, another, it is a hollow shaft, it is pi d power 4 minus small d power 4 divided by 16 to tau. It is the torque developed by the hollow shaft. So in both cases, torque developed by these two shafts is same, and it is having same maximum shear stress. Okay. Now compare, equate these two, we'll get, that is equate these two, pi d1 cube tau divided by 16 is equivalent to pi d2 power 4 minus small d power 4 divided by 16 d2. So equate these two, it will be cancelled, pi 16 tau will get cancelled, and t1 power 3 is equivalent to d2 power 4 minus small d power 4 divided by d2. Okay, so here expanding this, we'll get d2 power 4 minus small d2 power 4 into 0.7 power 4. So calculation will get d1 is equivalent to 0.91254 times d2. This is the equation B. So now what we have to do in this problem is compare the weights. Compare means compare means ratio between the weights. Compare the weights of the solid shaft. Okay. So what is the weight of the solid shaft and hollow shaft? The solid shaft weight is Ws. And Ws is equivalent to, so area of cross section of this solid shaft, area of cross section of this solid shaft and length, product of these two, you will get the volume. Okay, this is the area of the solid shaft and this is the length, into density, weight density. Metal is same for the both shafts. Then what is the hollow shaft weight, WH? So it is the area of cross section, H line. This is the area of cross section. This area and this length, product of these two will get the volume. Okay, into density gives the total weight of the shaft. So here rho gets cancelled, lengths are same, lengths cancel, only areas remain. So what is area of the solid shaft? That is PD1 power 4 by d1 square by 4 by d2 square minus small d power by small d square by 4. This is the known formula, well known formula. So here pi 4 get cancelled, and what remains? It is the d1 square minus small d2 square, d1 square minus d1 square by d2 square minus small d square. Substitute the equation B here. Substitute the equation B here. So you know that it is from A. Okay. By substituting A here, you are getting the D1 solid shaft outer diameter, solid shaft diameter, and hollow shaft outer diameter relation. Then substitute this here, you will get the D1 is equivalent to 0.925 D2, that is whole square. Okay. Now substitute this value also here, that D2 minus small d2 is 0.7 times d2 square means whole square. Okay. So this is the d2 pulled out, d2 square get cancelled, d2 square pulled out, d2 square get cancelled. So what you are getting? Weight ratios, that is the weight comparison. If weight of the hollow shaft is 1 kg and the weight of the solid shaft is 1.632 kg, so that means you are saving this much of material while producing the hollow shaft instead of solid shaft. అంటే ఇక్కడ సాలిడ్ షాఫ్ట్ యొక్క మెటీరియల్ రిక్వైర్మెంట్ ఎక్కువగా ఉంటుంది, హాలో షాఫ్ట్ యొక్క మెటీరియల్ రిక్వైర్మెంట్ తక్కువగా ఉంటుంది. సేమ్ పవర్ ట్రాన్స్మిట్ చేస్తున్నప్పటికీ కూడా మనం ప్రొపెల్లర్ షాఫ్ట్స్లోనూ చాలా ఇంజిన్ షాఫ్ట్స్లోనూ ఇంకా వీటిలో ఎక్కువగా మిషనరీస్, పెద్ద పెద్ద మిషనరీస్లో కూడా హాలో షాఫ్ట్స్ని ఎక్కువ వాడుతుంటాం. ఎందుకంటే వెయిట్ తక్కువగా ఉంటుంది కాబట్టి. అంతేకాకుండా వెయిట్ ఎక్కువగా ఉంటే బెండింగ్ మూమెంట్ ఇంక్రీజ్ అవుతుంది, బెండింగ్ స్ట్రెస్సెస్ డెవలప్ అవుతుంది. అందుకోసం వెయిట్ తక్కువగా ఉంటే ఆ షాఫ్ట్ అనేది పవర్ ట్రాన్స్మిషన్కి బాగా కంఫర్ట్ అవుతుంది. దానికోసం ఈ టైప్ ప్రాబ్లమ్స్ అడుగుతూ ఉంటారు. ఇంకొక దిస్ ఇఫ్ యూ అజ్యూమ్ దిస్ ఇస్ ఏ అండ్ వాట్ ఈస్ అనదర్ క్వశ్చన్ దట్ ఈస్ ఫర్ ద సేమ్ కండిషన్స్ యూ హ్యావ్ టు, for these two conditions, same torque, same maximum shear stress, maximum same length, same material. Same material means that is G here and G here is same. What is G? This is shear modulus. Shear modulus in this shaft, shear modulus in this shaft is same. Now another question may ask in many of the competition examinations and regular examinations, that is what is the percentage of weight saving? That is what is the percentage of weight saving by using solid shaft? So how can you solve this percentage of weight saving? That is comparison, that is difference between using solid shaft, weight of the hollow shaft. This is the difference of weight, material saved, divided by weight of the solid shaft. అంటే వెయిట్ ఆఫ్ సాలిడ్ షాఫ్ట్ని వాడితే ఇంత మెటీరియల్ వాడాలి, సాలిడ్ షాఫ్ట్ బదులు హాలో షాఫ్ట్ వాడితే ఇంత మెటీరియల్ మనం తీసేస్తున్నాం, ఇంత వెయిట్ మెటీరియల్. కాబట్టి ఎంత వెయిట్ మెటీరియల్ మనం సేవ్ చేసి ఇంకొక షాఫ్ట్కి తయారు చేయడానికి వాడతాము అనే క్వశ్చన్ ఎక్కువగా అడుగుతుంటాడు. సో దీన్ని ఇంకా చేయొచ్చు, మీరు సబ్స్టిట్యూట్ చేసుకోండి హ్యాపీగానే. సో వాట్ ఈస్ ద వెయిట్ ఆఫ్ ది సాలిడ్ షాఫ్ట్? దట్ ఈస్ పై d1 square by 4 minus, that is hollow shaft, already I have written, that is pi d2 square minus small d square by 4. Okay, lengths are same, divide by, that is pi d1 square by 4 into L into rho. Okay, these two terms will get cancelled. Okay, pulling out this, it will also cancel. What will remain? That is d1 square minus d2 square minus d, that is whatever it may be, what it has given in terms of that ratios. Okay, divided by d1 square. This is the mostly popular problem in any of the competition examinations. So if you remember this percentage of weight formula, that is d1 square minus small d2 square minus d square divided by d1 square, you will get the value. So by substituting only with ratios between outer diameter and inner diameter of the shaft of hollow type, if you know the ratios, you can easily get the percentage of weight ratio. This is the standard formula. Okay, so like this you can solve.